Okay, thank you. So thanks, Ben. Love the opportunity to talk to everybody. But before I start, I'd like to start by thanking Ben and Justin and everybody of the organizers, right? So I know I've organized events in the past, and I realize I know how difficult it is to do everything, and I also realized when we sponsored the ice cream how expensive it is. So thanks, Ben, Justin, and everybody for organizing the conference. As usual, it's pretty informative, a lot of people. So thanks for doing that. Appreciate it. So what we're going to talk about is a little bit of what Chris Wright mentioned, other people mentioned in the morning. We haven't rehearsed it. It's not a tie-in. Yay, Chris. So it's a whole collection of everything. Justin, I just thanked you for organizing it, in case you missed it. So what we are going to do is I know with the talks are a lot about technical, so I'm going to start with a high level. We'll go to a technical details, etc. But imagine that you have a problem, your tummy hurts, and your doctor has no tools. So imagine that there is something wrong with you. I know this picture might bring some horror stories or scary thoughts from you in your background. All of us, I think, we hated biology, so that's why we became engineers. Otherwise, we might have been doctors. So I apologize for that. But imagine that you have a skin and a liver and all this nervous system, etc., and your doctor has zero tools, like just a pulse, not even a pulse checker. So no MRIs, no X-rays, no nothing, just basic stuff. So why am I talking about all of this? So all these talks, all these solutions, problems, layers and layers of software that we are talking about is becoming almost like a human body. So your doctor assumes that things are set up properly, everything is fine, the hip bone is connected to the right bone, etc. You can tell my biology and physiology is zero. I just had one class in biology and ran away. Anyhow, so you can imagine that your doctor assumes everything is set up right, but maybe there's not something set up right. How do you do it without an X-ray, without a stethoscope, without anything? So complex network setup. So now let's talk more about networking. I'll go to the crux of the matter. Kernel networking, user space networking, bonds, bridges, EB tables, IP tables, VLANs, team driver, OVS in the center of this, the orbit theme. By the way, I didn't plan it that way. It just comes out that way. OVS is in the center. Mega flows, namespaces, VXLANs, everything connected to everything and going back and forth, etc. And now there's a poor sap whose boss just said, hey, Joe, not Joe, some other Joe. Hey, Joe, can you go figure out this OVS thing and this DPDK thing and see how it works? And poor Joe has no idea what to do. So imagine the Dilbert boss comes in and says, hey, Dilbert, figure it out. And anywho. So we were going through all of this as well. Thomas Graf was sitting here. I think he's somewhere. He told me many years ago when we started working on this, and he goes, Rashid, the nightmare is when people start using this, because how are we going to debug this? How are we going to support this? And that's how the effort started, etc. So Jiri Ben's here, standing next to me. He's the guy who developed this tool called PlotNetConfig. It's his baby. He deserves all the credit. I'm just talking because of my dashing good looks, as you can see. So he developed this. He was struggling with, poor guy got some bug, and he was struggling with like network config, and like, what is connected where? What is happening? So he developed this tool called PlotNetConfig. It scans the network configuration on a host and literally draws a pretty picture. Literally and figuratively. I know how to use the correct word, correct places. But it literally and figuratively does draw a pretty picture of the network configuration. We'll show you some examples. Allows multiple front ends, can be connected to other stuff, etc. Works across namespaces. Just a single command, run on a host. Do you want me to do anything? No, mic's not on. OK. There is a button in the side later on. So PlotNetConfig does that and gives an output in a PDF form or other forms. So it shows the configuration of OVS, obviously, VLANs, tunnels, bridges, bonding, veth, you name it. And talking about names, it also works across namespaces and is able to match interfaces across namespaces. Because of multi-tenancy and Coke and Pepsi being in the same host or same hypervisor, namespaces are becoming more and more relevant. So this thing works across namespaces. So that's pretty cool. So this is an example. So what are we talking about? What am I trying to show here? So this is, after you run the command, you get the host, you get a picture like this. The green boxes show that the link is up. Gray show the link is down. Pink show that our end is up, but the other end is down. White dotted blocks are non-kernel interfaces, like flows.
More like VXLAN interface of the older OVS without lightweight tunnels.
Yeah.
Yep.
And the lines are actual connections between the interfaces.
Or maybe here in this example, veth0, which is in OVS DB, but this does not exist actually in the kernel.
So. Cool. So these slides will be available for you to read closely. So, so this is an actual example.
Yeah, this is OpenStack.
So this is an actual deployment. I know it's an eye test. It's an eye test on purpose. So this is an actual example that we got from a customer deployment. It's not made up. We have anonymized it, obviously. And we've also found out many times working with this that there are multiple people configuring stuff. And they sometimes are not talking to each other. So there are two people trying to install this. Some are using scripts. Some are using something else. Some are using hand stuff. And then there are people who are configuring stuff, and they are also not talking to each other. They're just logging in. So, and they are assuming some stuff which might or might not be true. And so this is just this on purpose. This is an actual full example. I have some zoomed in pictures of this that show more detail. Again, the slides will be available. I don't expect you to read all of this. But this is just an example of how complex the networking is getting, how many things are configured. And let me reemphasize again, this is all within one machine. So now imagine hundreds of machines, scalability, etc. It's just getting spaghetti all over the place. Okay, so how do we do this? How does Jiri does this? Some technical details about this. Jiri didn't really reinvent the whole thing by itself. It reads existing stuff. So it reads the data from the kernel using netlink and sysfs and other stuff. It scans the procfs. It uses the netNSID, and it communicates with the OVS DB server. So I'm not going to read every word of this because of time, but this is how all the stuff that it keeps in mind to take care of it. So more info, where to download it. It is obviously an open source project, completely freely downloadable, usable, etc. We are Red Hat, everything is open source, obviously. It's available GitHub, more information there. And then there is a blog. One of our PMs out of Israel wrote a blog about it as well, so you can read up more about that. And then on the left side, there are some more stuff that we are working on. We have this is Jiri's pet project, but he also has another person working with him now. So some things which are in the works is SRIOV, obviously, DPDK plus OVS, lightweight tunnel support, more OVS flows displays, display routing information, net filter rules, and obviously oven support eventually. Okay. Okay, so we gave you one example. We showed you one example of plotnetconfig. It's really powerful. I highly encourage you guys to use it, see what the picture it does. But this is now a tie-in to what Chris was saying earlier, or what I was mentioned earlier as well. So this is a request for call to arms as well. So when we are putting layers and layers of software on top of software, it's running on one CPU. It's very complicated, northbound, southbound, east-west, diagrams on diagrams. You've seen so many diagrams today. I presented a diagram in front of a customer. I kept it simple, and they kept saying, this is too simple. It's good, but it was so much stuff that I wanted to put on a diagram that I could not explain it well. So there's just, the diagrams are becoming so complicated. Imagine the code and the actual flows and the packet going through. So the packet, when it enters the system, it goes through like so many things. The poor packet is thinking like, what's going on with me? You know, it goes through so many different things. So when we are working on complex solutions, please think about installation, debugging, long-term support. Some of us in Red Hat have to support stuff for 13 years. Ugh. But that's how we make money. So it's not just about us, but if we really want this stuff to get better adoption, it's not enough anymore to have a technology for the sake of technology. It should solve a problem, obviously, but it should be less complicated. And if it is complicated, how do you do pulse checking? How do you see where the network packets are flowing, if they're flowing properly, etc.? So my request to all of us collectively is that when we are coding new stuff, we are coming up with brilliant ideas, please put some percentage of your neurons towards thinking about debuggability, maintainability, complexity, ease of use, that kind of stuff. I know that sounds like marketing fluff, but sorry, I apologize, I'm an engineer, but we have to make it work for a decade or so, especially if it gets deployed by a large customer. You would like to add something? Am I on time?
Well, I think we still have time, so maybe a few words about namespaces and stuff what
Sure.
PlotNetCfg actually does with namespaces, because it's quite funny stuff, because only the recent kernels get the ability to reliably match interfaces across namespaces. Could you show the diagram, the picture? Yeah. So for example, when we have a veth pair that is connected across two namespaces, here we have in NS1 and NS2, yeah, that one. So for example, to figure out which two exact interfaces are connected together, that's surprisingly hard. New kernels export this stuff, but old kernels don't. And PlotNetCfg tries to use some clever heuristics and clever algorithms to really try to match the interfaces and connect those. And if it's not sure, it will show you, it just show red border and doesn't guess. So
cool.
Yeah, just one example of what's hard when you try to do such stuff.
So if you have like personal POCs going on, or you have your own setups, etc., we can run PlotNetConfig on your system, even now, today, offline, and help you look at your own picture that you have on your host, and help you understand it and do some more debugging. So Jiri and myself are available if needed. I think we are done with our slides, Ben. So.
Let's thank our speakers. This looks like a really useful tool to me. If anybody has questions, please come up to the mics while we're waiting. So have you been using this in the wild for finding some problems, and has it been helpful?
Yes, absolutely. So we have taken it all the way to the edge of the wild, meaning that we have it part of our SOS report. So our global support services team, which is our support organization, we have made it part of their tools that they use. So for OpenStack debugging, etc., they use it quite often, and they draw a picture and take it to their network admin and say, this is what it's configured, and sometimes they say, oh yeah, that's not supposed to be like that.
Okay, so it's sort of, is it part of something like a standard dump that someone would send in when they have a problem then?
Yes.
Okay.
So a lot of times they deal with it within the customer side, but if the customer says, yeah, no, it makes sense, this is how it's supposed to be, but there still is a problem, then we look at it, Jiri looks at it, then we start debugging it. So it's part of our bug reporting process now.
So how much development time did it take?
I don't know. It's just, I think I'm working on that for a year, just here and there.
But probably
spend
not
a few days
time,
there,
yeah.
and then don't touch in 2 months. And
okay.
So
Yeah.
But I would say if he, correct me if I'm wrong, but if you had it full time, you were working on it maybe a month, 6 weeks-ish?
Could be.
Okay.
I don't
Yeah.
know. Could be.
So it's,
And it may have paid for itself by now.
oh, absolutely, absolutely, absolutely.
All right, let's take questions. I won't dominate the discussion.
I think he was here.
Who was first?
I think
Okay.
that gentleman over there was
Go ahead.
Good work, great work, thanks. Yeah, one of the future things the first one you mentioned was SRIOV. So what are the challenges there, and how do you have any ideas on how you're going to overcome them?
The worst challenge with SRIOV is that it's very hard to really get the relations between the interfaces. So find out which virtual functions belongs to which primary function, and that's only available in sysfs. And sysfs is per namespace, so I need to really mount a new sysfs directory for each namespace. And I switch to, and that's, yeah, it sucks. So yeah, it's possible to, and this is currently being implemented actually.
I just have a quick comment after looking at that OpenStack diagram that if you've created a system that makes network like that look like that, you should probably rethink the way the system's designed, and you're probably doing it wrong.
So I have a question about that
So it's not
diagram.
us. It's not us, by the way. Yeah.
It's the network orchestration system that created it.
And actually, we took these pictures and came to our OpenStack guys and showed that to them,
Yes.
and look what you cost. And
So I have a question about that before we move on to this question. Is this a complex diagram, or is there just a lot of, do you just have a lot of things that are similar that could be sort of grouped into something that would be easier to understand?
so it's like more things, more groups repeating themselves, like more guests and stuff like that. So
I mean, any diagram is going to have a lot of stuff on it if you have 1,000 VMs.
yeah.
Right. But
Yep.
this is, so
That's
it's
true.
not more, I mean, it's a combination, Ben. It's a combination.
Okay.
It's a combination of more of the same repeated, but it's also a lot complexity when it doesn't have to be complex, like that complex.
Okay.
So to build on what Jiri was saying was that we took this diagram and went to our OpenStack team and said, hey, why do you have an EB table on top of an IP table
Okay.
on top of a VLAN? And they said, oh, because of connection tracking. I said, oh, okay. Hey, Justin, can we do something about connection tracking? So that's how things evolved. And it's a real story. I mean, it's an actual story. I'm not making it up. So with connection tracking, some of this complexity will go away. They needed some of this complexity. But when they looked at it also, they said, yep, that's a problem. We will do something about it in Neutron, etc., after we have connection tracking available. So it is paying itself in dividend already.
Okay, great. I think you were next.
First of all, a comment about the SRIOV thing. I've worked on that in the past, and for years now, they've needed a coordinated management interface through like generic netlink in the PF driver to provide all the management information for the VF, because it's the one who knows what the VF is doing. It can ask the VF for information. The VF supplies information to the PF. In almost all designs, there's that communication pathway of some sort between the PF and the VF that has to be leveraged through a netlink interface. But that's just a comment. The question about your tool was, how far down into like kernel interfaces do you get with that? Is this just like, are you just looking like if config type information or IP stuff you get from IP link show, or?
So it really uses multiple sources for the data. So it doesn't run any commands. Okay. It really speaks to the kernel using netlink, IOCTLs,
okay.
and such stuff, and tries to, or builds the picture of the network configuration in memory, and then just dumps it to the output in a format that you choose.
Okay. Okay. So, all right. When you look at it, you're looking at it more from that sort of network interface thing, and it's like layer 3, layer 2 type information. Okay. Any layer 4 type?
So layer 4
available there, or
what do you mean by layer 4?
Well, what type of protocols are traveling over that particular interface, or something like that? If it's not there, it's no big. It's just I'm helping people debug things, and that's useful to know. So
we're doing tunnels.
Yeah.
So if UDP tunnels you consider L4, then
Okay.
Then we can do that.
Okay.
But nothing that's really higher than that, but can be added if it's useful. Sure.
Okay.
It can speak to applications too. It speaks with OVS DB using JSON to get information.
Okay.
So, yeah.
Looks really useful. I'm going to give it a try. Yeah.
Please do.
Hey,
And
Joe.
shameless plug, patch is welcome. So, so if you find something useful, please.
So I saw on the wish list OpenFlow flows there, and I wonder if you had any thoughts on how you might visualize that. And maybe this is sort of a question for the OpenFlow people that, maybe Mininet, I don't know. But it's sort of a challenging thing, particularly if you get a complex controller that's sending down lots and lots of flows. Like it's just...
That's a really great question, and if anybody has any great idea,
Patch is welcome.
just even ideas welcome. I put some thought into that, and yeah, I don't yet know. I have some ideas, but nothing that would really say, okay, yeah, that's it. Let's do it. Nothing like that.
Let's talk some more. I have some ideas as well.
That's another thing where just the sheer quantity could make the diagram overwhelming.
Yeah.
You could have 1 million OpenFlow flows in
Yep.
a large system easily.
Although the diagram over there is a repeat of the same several times, sometimes when you are debugging a problem with a specific VM, you need to know specifically to one group, one special case. So it's really great to have everything, even if it could be grouped in just a single instance. So, but another difficulty with the debugging in a customer environment is we are not allowed to install many things or many dependencies because the environment is very restricted. So could you please comment on the dependencies to run this tool?
So there are just 2 dependencies. One is glibc, and the second one is JSON library for JSON, but that can be built statically into the binary. So it's really boils down to glibc.
Okay, and what's the size of the tool, more or less?
I don't know. It's not big, so but yeah, I don't really know.
So it's tiny. So
It's tiny.
answer
it's
is tiny.
Tens of kilobytes, I would suppose, without debugging info, of course.
Thank you.
So it's a tiny tool. Thanks, Flavio. Good question. So it's a tiny tool and not a whole lot of external dependencies.
So one of the things is that the nice graphical diagrams, this post-processing by GraphViz, by the dot tool, and what plotnetcfg outputs is just the language, the dot language that the tool understands and then displays in this way. So you can also choose JSON output instead, and that's it for now.
Let's thank our speakers one more time.